And next, do I need to introduce anymore? Because Benjamin has done everything. He's introduced Scaphander and he's introduced Benoit. Benoit Small. Hello, Benoit Small. Sorry, Benoit Petit. Funny.
Hi.
Next speaker. So Benoit, he's sharing the same passion for tooling as Benjamin, also participate to the Boa Vista initiative. Benoit has developed a tool to get electricity consumption from machines, from bare metal, and maybe even more. And I guess he will tell us probably better than me about Scaphander. Hello, Benoit.
Hi. Thank you, Sebastian. First, I'd like to thank the organizers, as Benjamin, to allow me to give this presentation and to give such space to presentations related to sustainability, as it's a very, very important topic. We will talk about measuring the power and energy consumption of digital services from the servers. But just I wanted to mention that, as you guessed, I've not made this topic my work area for no reason. If I give this presentation, is because I want that we all work for a more sustainable digital industry that fits this century's challenges and constraints. But I think if you are looking an all-day session of sustainability presentations, that's also your mindset. So I'll first briefly introduce myself. My name is Benoit Petit. I'm the founder of Hubblo, which is a company that helps other organizations to measure, understand, and reduce the impact of their digital services on climate. And we'll talk about that just after. Before that, I was a site reliability engineer. And then I quit my job to work on that way more important topic. I'm also a member of Boa Vista, which is a working group of IT professionals trying to improve the methodologies to measure the impact of IT on the environment. And I think you will have a great presentation about Boa Vista during the day. So first, as I said, I work on this topic for a reason. Usually I start this presentation by talking about climate change itself, giving the big numbers, precising how urgent it is to reduce our footprint. But as I said, because you are here, I guess you already know all that. So I will skip directly to the impact of IT to explain why I developed Scaphander. So let's talk about digital. As a quick introduction, you may know that the GHG, the greenhouse gas emissions of digital, are about between 2 and 4% of the world's greenhouse gas emissions in 2020, and the current trend could lead us to could lead that number to 8% in 2025. So we are really not on let's say on numbers that we could ignore, and it's really urgent to act. But to be more precise, what are those emissions made of? Here you have estimates of those emissions divided by scopes in IT, which are user devices, networks, and data centers. We see that the user devices have the biggest impact, which is 63% of the greenhouse gas emissions. So we need to keep in mind that both as individuals and IT professionals, our first lever, and one of the most important, is to use our smartphones, laptop screens, and other digital devices as long as possible. Fix them, buy second-hand devices, not new devices. In the end, extend the lifetime of those devices as much as possible. We also know that the largest impact of those devices is their manufacturing. So we can say that the best device is the one we didn't buy new. But what I wanted to show you is that, and Benjamin introduced that topic before, is that greenhouse gas emissions are not the only impact of the digital industry. Way from that. The impacts are multiple, concerning water consumption, geological resources consumption, and so on. Primary energy consumption, electricity consumption can be also an issue. There are, I think these days there are protests in Ireland because there are data centers are consuming so much power that people start to have power surges. So it's also a matter of energetic lacks. Just to mention that, this presentation will be more about greenhouse gas emission, climate, and energy through the lens of energy consumption, which is one of the factors. But keep in mind that digital has an important impact on all those topics. And on some of them, it's very hard to get data. For example, regarding water, we estimate that less than a third of data centers are publishing their water consumption. So we don't know the real global impact about water today. And most of the time, we don't know its local impacts, which is often the most important topic. So let's talk briefly about electricity consumption. So this is supposed to be a quiz, but I will just give you the big numbers simply. We have several energy consumption numbers on the left in terawatt hours per year for the year of 2020. And the reasons for that energy consumption on the right. So we talk about electrical consumption, not primary energy consumption. So which is which? We'll do it very quickly just to have the context. If we take the electricity consumption of France, all industries included, we are about 480 terawatt hour a year. If we take digital in the world, we are about 1,400 terawatt hour in 2020. Some studies say 1,200, some others say 1,800, but the average, let's say the average is about that. And the last point is, if we focus on that presentation, the data centers in the world would consume between 200 and 800 terawatt hour a year. Maybe you're like me, and then you notice what is that difference between the studies. Does that make any sense? As it's a difference from a multiplication of four times the first value. So the reason for that is that ICT is really an opaque world. We are really strong to gather metrics about business, about data, about people, about money, but we are really, really bad at measuring our impact on the environment. That's one of the things I wanted to contribute to fix. And the second thing that I wanted to mention is the trend, because it's not enough to have a picture of the situation today. Even the studies that consider the lowest scenario of data center consuming, let's say, only 200 terawatt hour of electricity per year, even those studies forecast that the energy consumption of data center could explode. And exploding means that the energy consumption could be tripled from these days to 2K30, so which is in 9 years. Why is that? Among the hypotheses is there is one of the reasons maybe that Moore's law is about to end, is already ending, and it's causing Kume's law, which says that we get more powerful equipment every 2 years for the same power consumed, for the same energy efficiency. So all those laws, we are not really sure that they will continue like that. For Moore's law, it's pretty sure that it's already in the end. And more broadly, it seems we have an exhaustion of the means of optimizing power consumption that we benefited until now. The average of PUEs seems also to have reached a limit in the recent years. So in the end, we are really not aligned with digital, some say digital sobriety, let's say sustainability. And it's useless to hope that only power consumption optimizations will fix that on the subtopic of electricity consumption. So both regarding the opacity of IT and those trends that we need to change, those two reasons are the ones why I created Hubblo and started to work on publishing open source software to help measuring the impact of IT, and then give insights to help to reduce it. So let's talk about Scaphander. Scaphander is a lightweight agent that you can install on your servers, and that will give you the power consumption of the server and of each service running on the machine. Here is the mindset behind the project. We aim at providing transparency where there is none. We talked about that. It is also a replicable method to measure energy consumption. It's easy to install and use, and it's of course open source, so the methodology can be criticized and improved in a collaborative way, and you are very much encouraged to contribute to the project and to criticize so that we can improve the tool. It's a light tool, both in terms of resources, of IT resources consumed, and in terms of system administration required to make it work. It's extensible, which means that the architecture of Scaphander allows to develop, to create new exporters for each monitoring tool or that data analyzing tool that you would like to use to analyze your data and to focus on it. And this way, Scaphander adapts to the stack, to your monitoring stack already in-house, and not the opposite. You don't have to change anything in your stack to make it, to integrate power consumption metrics. So I'll perform a quick demo. Just have to share another screen. So I have on my machine, I have a Kubernetes cluster running. So Kubernetes is very famous these days to, do you see my terminal, just to be sure? Yeah. Okay. So Kubernetes is very famous these days to run multiple digital services, including APIs. What I wanted to show you is that you can install Scaphander as a daemon set. So you see that, so a daemon set, this is the deployment that will install one instance on Scaphander on each node of the cluster. We can see that on this cluster, I have an application running, and I have the pod of Scaphander running too. So Scaphander is measuring the power consumption of our application and of other pods on the cluster. I will just show you what the application does. It's a very simple application. It gives me the Fibonacci sequence every time you call it. And we will generate some fake client traffic so that we can go on the monitoring and see what happens. So I have to switch screen, so sorry for that, but keep in mind that we are running fake traffic on the background. And so here we have an example dashboard of what you can get with Scaphander. So we see that Scaphander gives you the power consumption of the server itself, the whole power consumption. So this is the power consumption of my machine. We see that you can stack those metrics to get the energy consumption that you can communicate in watt hour, kilowatt hour, etc. and that you can get the power consumption per process on the machine. So this is like the power consumption of each process on the machine stacked. But if you zoom on it, you see that we have the power consumption per process, per system process. So that's interesting, but maybe we will want to look at things closer. So for example, if I want to look at, I think I can find my application now, for example, because if I take, for example, my browser, oops, sorry for that. So my process filter is maybe broken, so we will focus on the Kubernetes part. So this is like the basic power metrics that you get with Scaphander, with a bare metal machine. But because we said we are on Kubernetes, what we are interested in is the power consumption per pods and per Kubernetes objects, application services, and so on. So my formula is bad here because we are in microwatts. So I have to divide it to get the watts. So here I see that I have the power consumption per pod with the detail. That's exactly the same mechanism behind the scene as this graph. It's just that that when you tell to Scaphander that he is running on a Kubernetes cluster, it will apply labels to the metrics so that you can know which metrics are for which pod. And we can go further. We could also get the power consumption for pods that are in a specific namespace, which can be interesting because most of the time we manage the applications in namespaces. So what we can do, for example, is we will filter not on pod names, but on pod namespace. And for example, I will take only the metrics for my default namespace because I don't want to see the kube system namespace and all the internals of Kubernetes. I just want to see my current namespace. So that's another example. I'm just wondering why I should get. Am I querying the right application? That's the question. For the cluster. Okay. I think I'm not querying the right. Okay, sorry about that. So yeah, I should be generating traffic on this application, but I generated traffic on another container on my machine. But that's all right. You would just see the graphs going up. That was just the point. But you see that we have the details of the power consumption per application. It's just that it doesn't do much as I didn't query the right endpoint. So let's go back to the presentation after this short demo. Okay. So to clarify a bit more what Scaphander is and is not, it's a data collection tool. So it sends data in a given format to a given solution from the machine, and here from a Kubernetes cluster, for example. But it's not a tool that will store data or analyze it. It relies on tools that are made for that. So in our example, we were running Prometheus to store the data and query it, and Grafana to create the dashboard and show the data and analyze those data. But as I said, Scaphander is modular, so you could replace the data aggregation tool by something else, and we will see what we can support today. Or you could also use another tool to see the data and to analyze them. So here is an overview of the features we have so far. So you can measure the power consumption of a machine and its services on bare metal machines, exclusively with x86 CPUs so far, not IRM CPUs. You can see the power consumption and details per service in a virtual machine. Today, this is working only with QEMU KVM, which is the hypervisor, one of the hypervisor you can get on a Linux machine. It works with Kubernetes. We have seen an example there. You can install Scaphander thanks to the Helm package, so it's already automated. You can also run Scaphander in Docker Compose configuration to perform a quick test on your laptop, for example. This is available on the GitHub of the project. You can download the Docker Compose, just run Docker Compose up, and you have a demo. As we said, you have the power consumption per process, per service. And the features that I've highlighted in yellow are especially the exporters, so the tools to which we can send the data, so then you can store them and analyze them. So far, we have an exporter for Prometheus. We saw an example of it. We have an exporter for Riemann, another for Warp10, which are also monitoring tools. And you can also simply export the metrics in your command line, in your terminal, or in a JSON file. About the features to come, this is the big picture roadmap. We are going to release a version of Scaphander for Windows Server. It should be in the end of December, so very soon. Next year, the big topic will be public cloud. So how do you live estimate the power consumption of the virtual instances in the cloud? This will be the very big topic of next year. And in the end of next year, we should start to work on getting power consumption in other virtualization solutions than QEMU KVM. So, for example, OpenStack or VMware. Under the hood, Scaphander is written in Rust to have the lowest resources consumption possible. And today we are mostly relying on REPL, and I think Benjamin mentioned that, which is running average power limit, which is an interface with the CPU that helps us to get the power measurement. And I won't go into details as Benjamin was very clear about that, but just to mention that even regarding only the greenhouse gas emissions, there are several scopes to watch, and Scaphander is only about scope 2 and scope 2 of compute. So you don't have the full picture of your carbon emissions with only Scaphander. And I'll stop there, Sebastian.
You do have a picture, good. I will have time for one question, one brief one, because it's already almost 2. Question from Now Fell, I'm sorry about the pronunciation. Scaphander gets the power consumption of the machine hosting Kubernetes. So if we deploy it in Google Cloud, it will get also the power consumption of the data center. Is that correct?
Not exactly. Yeah, Scaphander gets the power consumption of the machine hosting Kubernetes. That's right. The point with Google Cloud is what I said, is that today it doesn't work on virtual instances in the cloud. It's for 2022. So far, if you deploy a Kubernetes cluster on Google Cloud, you won't get the power consumption with Scaphander, unfortunately. But stay tuned in 2022. That may happen.
Brilliant. Very good. Thank you, Benoit. Great presentation. And I'll see you also very soon, hopefully.